Okay, so let's start with a question, daily question on LeetCode, which is based on rotating the images. So now let's see how the question asks us to rotate the array. Okay, so let me read the question. You are given an n cross n 2D matrix representing a image. Okay, rotating the image by 90-degree clockwise, you have to rotate the image in place. In place means we don't have to use the extra space to replace the array, which means you have to modify the input 2D matrix directly. Do not allocate another 2D matrix and do the rotation. Okay. So there are two examples given here. So we just have to take an example and let us understand what the question is talking about. So let's take this example and move it to our blackboard. Okay. So let's just make a matrix for self to use. Okay. So that's the matrix for self to use. Okay. So we can take it as a matrix. So we have to take the duplicate out of it so we can understand easily. So what the rotating of an matrix means, rotation of an matrix means if we just have to rotate the matrix, we rotation needs rotation. What the rotation needs? Rotation needs two steps. First is to transpose the matrix, transpose. Second step is to swap rows. Okay, for rotating to 90-degree. That's the proper approach. For the rotation of 90-degree, you just have to transpose and swap each row. And if you want to just rotate 180-degree, 180-degree rotation, do that twice. Okay, if you want in just 180-degree rotation, do that twice. 90-degree rotation. Okay, so just to rotate the array 2D array to 180 degrees, you just have to perform two times the rotation of 90 degree. So two times the rotation of 90 degree, two times 90-degree rotation. Okay, two times of 90-degree rotation. So let's just transpose. Now let us understand what is the transpose means. Transpose means is to keep same the diagonal elements and rotate each elements here. So let me make you clear with the laser. So we just have to keep these diagonal elements as same place and rotate this indexes like this and this indexes. Yeah. So let me do it a certain dry run for you. So let us first transpose. Okay, so transpose. Let us first transpose. So transposing the matrix means keeping the if I and transposing matrix means just keeping the I and j row column same and rotate each other columns. So we have to just keep same where I equal to j. We have to just keep the same element as in the array. Okay. And now we just have to transpose these things and we have to take 7 and 3 and we just have to take the and 6. Okay. So that's easy. Now we just have to take the second step. Second step is to rotate, swap row wise. Okay, swap row wise. So row wise swapping needs 4, 1, 8, 5, 2, 9, 6, 3. Okay, 9, 6, 3, 9, 6, 3. So that's equal to the matrix we have to make. Okay, so we just have to rotate the matrix. First step is to transpose, second step is to swap. Okay, now just we can write the pseudocode from this. So to write the pseudocode from this, we just have to pseudocode out of it. Okay, we just have to write the pseudocode out of it. So thereby we will just need certain things for pseudocode. We just have to first transpose the matrix, and then we just have to uh, row wise, row wise swap, row wise swap. Okay. So for transposing, that's the thing we will discuss. Okay. So we just have to transpose and row wise swapping. Let's write the code for pseudo code for transpose. What do you mean by transposing a matrix? What do you mean by transposing a matrix? So let's write a code for transposition. Transposing a matrix. Trans. So let's actually understand the transpose, as I'm also doing that question to the first time, like understanding the question. As I'm making the video to just showcase my skills to the interviewer, as I'm debugging the question in front of, right in front of camera. So transposing the matrix. So what do you mean by transposing? So transposing, this is the term transposing. We just have to traverse to each and every element of it. So what do we mean by that? So transposing means we just have to take a for loop I from 0 to that we have to traverse row wise. So we have to traverse the row wise, and again a for loop which starts from j equal to 0 to columns. Okay. So we just have two things, row to column. Now, if I equal to j, we just have to continue. Continue. As I told you previously, that I and j's continue means we just have to keep the diagonal element similar. So now, what do we mean? What do we need to change actually? What do we need to change actually is these elements. So how can we take that? So we can just and make it a duplicate, and we can transfer it to bottom. Okay, good. So what can we do now? We just have to transpose this. So on transposing, what we are changing, what we are changing. So that's the 0, 1, 2, 0, 1, 2. So the location array of 0 comma 1 is swapped by array of 1 comma 0. So that's the thing we have to mention here, as now we have to mention the value int. We just have to swap the values. Okay, we just have to swap the values. So let's swap the values. Swap the values. Swapping values need a third person, a temp, which the temp is equals to ARR of I of j. That's my current state, I of j. And that ARR of j of I equal to ARR of j of I equal to. So we can write just simply swapping of two elements. Na? It is a pseudocode, so we can write just a swapping of two elements. Okay. So for pseudocode, we can just write the swapping of two elements. So swap array of I j2 array of j and I. Okay. So that's the thing. So a thing we just remembered, that if we traverse from 1 to, if we traverse whole array, we can end up traversing the elements twice and swapping the element twice. So it will not change the location of the elements. So we just need to modify the first row traversal. Row traversal should is row traversal. No, we just have to modify the column traversal. Column traversal should start from ith position. Okay, if we are at 0th row, it will be the column will start from 0. If we are at the first row, the column will start at 0. So at the end, we just have to traverse this type of things. We just have to traverse the half of the matrix and the upper diagonal of the matrix, upper half of the matrix. Okay. If in the first iteration we will swap 2 to 4, then if we go in the second iteration to the 4, then we will again swap 4 to 2. So we just have to replace this with I. Okay. So now let's replace this with I. Okay. That's the perfect transpose example. Now let us move to swapping of each element. So swapping each row, Okay. Now swapping each row means we just have to go to the array, and we can be like array dot reverse, but here we can't apply that. So we just have to take the array int arr of that matrix we have been given. So now we have to take a pointer I and pointer j to just swap the elements. Swap all element of each row. Okay. So that's the total transpose, and swapping algorithm is there. Swapping pseudocode is there. So now let us just code it up in the IntelliJ idea. So I have taken the IntelliJ idea to code. Okay. So what we gonna code? We just have to see the pseudocode we have given, and just we have to code it up. So we have to do transpose, and we have to code for swapping the elements. So code for transpose will be as the swapping of element. So we just have to do transpose, and we just have to swap the elements, swap the elements in each row. Okay. So transpose means we just have to traverse from I equal to 0 to, just we can take the row and column separately. Na? Matrix dot length is the row, and column is matrix of 0 of length is the column. So we have taken the row and column. That's a quite good thing. We can keep the code clear. Okay. So int j, what we have decided? We have decided to keep it to start from I, and go till column j plus plus. Okay. Now if I equal to j, then we can continue that iteration. And if there will be a second iteration, if that will be a non-diagonal element, we have to just swap it. So matrix of I and j, that's the third temp variable we are taking. So we have taken the value of I comma j to temp. Okay. Now we can assign the matrix of I comma j as matrix of j of I. So that's the pretty easy type of swapping here. So we can also swap by don't having the temp element. Okay. So that's the transpose. And now let's do the swapping of each array. So take each array of matrix. Now do arrays dot, it's not the type of arrays dot reverse. I equal to 0, then j equal to arr dot length. Okay. So while I less than j, we just have to swap the things. So swapping means just change the things. Okay. I and j, we need to change we can change array of I with the array of j. Temp. I think this is right. So I plus plus and j minus minus. So that's the transpose of. So let's take a quick look over it. I equal to 0 and I is less than row. So we can also format it. I equal to 0, I is less than row, j is starting from I, j is going less than column, j plus plus, and we are just doing the things. And for swapping, we have taken the array dot length, I less than j. We have just used temporary, and let's run it. I can see there is an error. Error of what? There is an exception. Index 3 out of bound of length 3. Index 3 out of bound of length 3. I think might solve the error. Okay, so we have just passed the two test cases of it. We have just passed the two test cases. Let us paste it to the LeetCode. We have successfully passed the two test cases, and also, oh my god, we have just completed 1 day of a streak and passed all the test cases too. Okay, so now let's talk about the time complexity of it. So let's take a screenshot of it and we will talk about the time complexity. So let's have the screenshot. Yeah, we will have the screenshot of it with us. Okay, now let's discuss the screenshot. So we have to discuss the space and time complexity of it. So as you know, the space complexity of it is big O of 1, as we are doing it within the array and inbound of arrays. What do we call that? We what do we call that thing? Is in place. In place swapping is there. So no extra auxiliary space we have used. So time complexity is we are going from row and column. So at worst case, we will go big O of n square. Okay, because n and again big O of n square, big O of n square. So we can add both. So the time complexity will be big O of n square. Okay, as we are traversing the array two times n square. Okay, thank you.